Welcome to American Energy Technologies Company's Tech Talk. We are excited to share the next 10 minutes of your time and explain how we have worked to become a cutting-edge member of the United States hypersonic community as a supplier with our newly developed technology. We'll start off with a brief introduction of our company. American Energy Technologies Company, or AETC, is a U.S.-based, privately owned and operated, women-owned small business located in the northeast suburbs of Chicago. Founded in May of 2009, AETC currently operates 3 business units in the Chicagoland area, to include a manufacturing plant for graphite and carbon production, pilot demonstration facility or advanced materials, dispersions, and form-factored shapes and parts, as well as a fully functional R&D laboratory, supporting the aforementioned business ventures. AETC currently has over 100 customers globally, in hubs such as Europe, Canada, Australia, and New Zealand. Our top-of-the-line R&D facility is dedicated to the support of sales of our products into composite, battery, and advanced graphite and carbon industries. We have dedicated mechanical, chemical, and electrical engineering departments, an excellent machine shop, and an in-house fabrication and prototyping facility. We are a proud member of the domestic supply chain of EV batteries and are an approved supplier to many Department of Defense primes. Along with our extensive work with commercial clients, we also do work with the government on contract R&D via SBIR and non-SBIR initiatives. What technology have we developed that primes need? Currently, ramjet and rocket technology is undergoing massive innovation, with the industry attempting to transition from traditional fuel technologies into a more advanced metallized fuel component, which could drastically improve the range and performance of rocket-powered munitions. With this in mind, AETC developed an innovative, carbon-based ablative nozzle liner that will maximize the combustion performance of an entirely new generation of rockets operating with the aforementioned advanced fuel. In order for this fuel to be rated for use in advanced rocketry systems, a more robust, higher-temperature material that can properly manage the energy contribution to the thrust is required for the nozzle insert. The thrust contribution, which is currently not a feature of traditional nozzle insert manufacturing technologies, will allow for increased performance and a substantially longer flight range. This particular nozzle insert technology, which has been developed, also has a unique application utility in solid fuel ramjets. In order for this fuel to be rated for use in advanced rocketry systems, a more robust, higher-temperature material that can properly manage the energy contribution to the thrust is required for the nozzle insert. The thrust contribution, which is currently not a feature of traditional nozzle insert manufacturing technologies, will allow for increased performance and a substantially longer flight range. This particular nozzle insert technology, which has been developed, also has a unique application utility in solid fuel ramjets. What has been improved? AETC's nozzle technology was developed in order to improve the utilization of metallized fuel in air-breathing applications. The technology offers an improved thermal conductivity and increased reflectivity, withstanding the high temperatures generated in advanced fuel systems, with a longer burn endurance, leading to increased thrust and performance of the rocket vehicle. AETC's nozzles provide a contribution for the after-the-throat energy release to the rocket's thrust, which, in turn, will allow for a substantially longer target range. The new nozzle is comprised of a graphite-based material so as to optimize the thermal and mechanical properties of the nozzles, making them adaptable to any rocket engine or fuel type. These nozzles are made using 100% domestic materials, designed to facilitate increased range and performance for lower cost than the current incumbent ISO-molded nozzle technologies. More specifically, traditional technology is manufactured via large billets, which are up to 60 inches in diameter. Please refer to Figure A. This method requires extensive labor and incredibly expensive and large equipment. The billets are precision machined down into discrete parts, sized to the diameter for the ablative nozzle inserts. Considering how large the billets are to begin with, A significant amount of the expensive, iso-molded graphite ends up in the process waste stream to create the final product. Our uniaxial compression molding and precision die capabilities are utilized in order to manufacture our ablative nozzle parts, instead of using the large billets, allowing for major cost savings over traditional technology. Our primary objective in developing this technology was to prevent the oxidation phase in the nozzle. AETC's advanced capabilities has thus far resulted in the fabrication of several candidate carbon composite materials uniquely suited for new formulations of solid rocket fuel. This project is currently situated on TRL-5, with a projected TRL-8 ending. AETC will require additional funding following the SBIR contract end date in order to enable the production of form-factored prototypes for testing. AETC will demonstrate our ability to produce the prototypes, generating them for qualification testing at Naval Air Warfare Center, Weapons Division, China Lake. Successful technology validation by government testing facilities will open a pathway towards the commercialization and upscaled production of the nozzle parts in order to integrate them with primes such as Lockheed, Raytheon, and Boeing. AETC is looking to generate interest within the Department of Defense, with organizations such as the Army Special Missile Defense Command, the MDA, NASA, and more. A few advantages and benefits of the technology include its ability to enable potent, advanced metallized fuel, so as to dramatically improve thrust, range, and rocket performance in rocket engines. Since these fuels typically require a more robust, higher-temperature material, AETC's technology can maximize the combustion performance of new-generation rocket fuels. Our nozzles are also suitable for all current and future production rocket-powered munitions. AETC is seeking to establish domestic production of carbon-based rocket nozzle inserts, as there are currently no domestic suppliers of a critical component of rocket-powered weapons. Gaining a domestic supplier of nozzle inserts would be a major opportunity, so as to harmonize the development of advanced rocket fuels and nozzle inserts that can be optimized alongside them. AETC's reduced manufacturing costs and shorter lead times, with the increased transparency of the supply chain, are a few other added benefits. As a method of transition into the fleet, NOC-WD China Lake recently secured internal funding to begin performance validation testing on AETC's nozzle inserts, compared to the control laboratory formulation. AETC will use the remainder of Phase 2 in order to support the evaluation program and produce parts in accordance with MIL specs. The nozzle prototypes are anticipated to be delivered to NOC-WD in February of 2024 to undergo a full year of testing. SBIR Phase 2 enhancement will be required in order for AETC to continue making samples for the China Lake standards testing, with a specific budget in mind to be allocated for synthesizing the nozzle parts. AETC has plans to work with industry personnel from DoD primes, as well as smaller companies, in order to completely evaluate the technology once release is approved by the government. AETC is looking to transition the nozzle technology into primes using metallized fuels and propellants, in order to establish a domestic supply chain for the nozzle inserts. We are seeking an introduction to primes such as Lockheed Martin or Raytheon, or similar partners that work closely on the development of rocket-powered munitions and missiles. The engineering work of this endeavor targets the emerging advanced metallic solid fuels, which are created using enhanced elemental boron. NAVAIR has expressed interest in validating this fuel technology for use in future weapons. It is expected that a wide array of rocket systems will benefit from this technology, ranging from DoD and NASA vehicles to those developed in hobby rocketry. The technology is also anticipated to support the ultra-high-temperature, continuous fluidized bed furnace industries, which operate on similar principle. To wrap up, AETC is always excited to meet with and speak to new customers and primes. We would love the opportunity to collaborate with any company or organization that has interest in our technology and the advancements described in this presentation. Contact information is listed on this slide, as well as our website, so you can explore many of the other projects we dedicate our research to. We would love to hear from you. We look forward to working with you in the future. Another email is listed on this page for reference. Please feel free to reach out to Ms. Doninger or Dr. Barsakov in order to learn more about what AETC can do for you.